and the Ethernet cables. Okay, so that's pretty neat. So what I recommend is you can get this kit and have everything you need not only to get the Pi up and running, but you also got some things that you can start building some projects with. You've got the power supply that you need, some buttons, you got sort of a breakout board and ribbon cable so that you can bring the signals out and start working between the Pi and the circuit. Sort of like the types of things we were doing with the SparkFun Inventor kit when we were working on Arduino. So I really recommend this kit. The other thing I recommend is to come down just a little bit below that. If your monitor has a DVI input, and let me see, I have a DVI cable here to show you. I'm not seeing my DVI cable. So a lot of the monitors don't want HDMI inputs, but they will take DVI. If you look here, maybe I've got a picture of it here. Yeah, you can plug this end into the Arduino and then look at your computer and see if it has a DVI input on your monitor. A lot of your monitors will have these DVI inputs, and therefore, if you have a DVI input besides the chip, you would need to get this cable. Again, I give that link on my website. Finally, if you're really using an old monitor, that only has a VGA input, you will need this. Check the link here, the VGA projector adapter. I've gotten this to work with the Raspberry Pi. This end goes in the Raspberry Pi. This one you then just use a single VGA cable. But this actually has in here the converter that converts the HDMI signal to the VGA signal. So this one actually works. So what I really recommend is I recommend that you get the kit. I think you can try to put these things together on your own, but by the time you get it all put together, you're probably going to pay as much or more as getting it all at once. And what I can say is if you work with these things and they actually work, the power supply works, with the good SD card, the case is nice, and then you've got these breakouts and so forth. So this is the gear that we're going to be using in these lessons, and it's really what I recommend that you get. Let me just say a little bit more about this Raspberry Pi. If you're using the Arduino, you run the Arduino, you write a program on your PC, you dump it into the Arduino, and then the Arduino switches. It's really, really powerful for working with circuit elements, for working with sensors or actuators. It's very good at those things, but it's not very interactive. There's no graphics capability. You just have sort of a very limited ability to interact with it. There's no on-board operating system that you can work in. You write your program, you download it into it, and then this goes and does your thing. The second is that the Raspberry Pi is more like a full-fledged desktop computer. When we start in my lesson, first of all, I'll show you how to just get things installed and get it booted and up and running. After that, what we're going to be doing is we're going to be learning Linux. Now, we're going to be learning the practical Linux that you need to either isolate around the operating system, install software, copy things, move things, delete things, isolate around. And we're going to be doing that by, in these lessons, learning the command line. And so here you can see we have a terminal window. I can see my LS, and I can see where I am and what programs are there. I can change directories. I can do things like that, work my way around. We're going to start by learning Linux because really, if we're going to be doing this, you need to learn Linux. Okay, so we're going to start with command line. We're going to start the command line window, the terminal window, and we're going to learn how to operate the computer from the command line. If you have never done this, it's really fun. It's like you really don't want to go back and start using Windows again once you get good at the Linux command line. So we're going to learn the Linux command line, how to install things, how to do all that. After that, what we're going to learn is that you can actually boot the Pi up, not in the command line, but you can boot the Pi up with something that looks a lot like Microsoft Windows here. You can see that we've got a menu, we've got different programs that we can run. There's actually a free version of something very similar to Office, Microsoft Office, where you can get a word processor running, we can get graphics running. We can do almost anything on this Raspberry Pi that you can do in a full-fledged Windows-based desktop computer. And so we will go in and we'll show you how to get this stuff going, but like I say, when we start, we're going to be booting up in the terminal window, and we're really going to learn something, because if we just go into Windows, you might as well just buy a laptop and sit and program on a laptop. To really learn the system, you need to learn how to operate a computer from the terminal window. Okay? So to kind of summarize, we love the Arduino. We will still be using the Arduino, and eventually what we're going to be using is the Raspberry Pi to do the heavy computation, but still I like using the Arduino to control these sensors or to control the actuators. So a lot of times what we're going to be using is taking advantage of each one. The Arduino is very good for instrument control, sensor control, operating servos and actuators, and then the Raspberry Pi is good for doing the graphics or manipulating screens or doing things like that. So in a lot of projects we'll be using both of these. But since you only want to use the Arduino, we're just going to start now by learning how to use Raspberry Pi. So tune in with our next lesson. In a couple of days I should have the next lesson up, which will actually show you how to download the operating system to the SD card and to boot up the Raspberry Pi. Okay, Sam McClure at PopTechGuru.com. Hope you'll think about subscribing to my channel and maybe give me a thumbs up on the video. Take it easy, guys, and we will see you on lesson 2.
new interesting dualities. And as I was writing this lecture, I realized there was a lot of material, and you all have been such a feisty audience that I could imagine we'd get stuck for most of the period on any item on the list. And so I look at the list and get nervous and cut out questions, probably. And actually, the first two are probably the longest single items. So last time we talked about staying within a given equal part theory, say, and just looking at non-uniform vacuum of the Coulomb branch. The next simplest thing would be to perturb the theory a little bit, to add some relevant operator to the Hamiltonian density of the CFT, and I'll suppose here this is irrelevant, delta less than Z. If it's irrelevant, it does nothing at low energy. It blows up into UV, and you don't really have a theory anymore in general. Actually, the case delta equals Z is interesting, but there's only so much time, so I'll just put a few references in the notes. Anyway, with delta less than D, this is something which becomes effectively larger as you flow to lower energies, and so to change the low energy physics. And we know how to study this in the dual theory, in the gravity theory, because this is adding this to the Hamiltonian is just what we've been doing to make it generating functional. And we've been thinking generating functional is just being a way to generate the correlated to the original theory, but it's equally well a quantum field theory in its own right. So with the sign conventions I was using, this is taking that J of X I was